Section 20.2 Ohm's Law. So as I mentioned in the last video, we're going to get into the relationship between the electric potential or the voltage, the current, and the resistance. Now, what is this resistance? The resistance is more than something in Star Wars, right? It is defined as the ratio of the voltage applied across a material to the current through the material. So it's defined actually in terms of this voltage and current. And we note it with the symbol R. So the way we can write that sentence mathematically is as a ratio. And this is what makes up Ohm's law. Ohm's law says that that ratio, voltage divided by current, is a constant. And that constant is known as the resistance, R. So V divided by I is equal to R. Or the way that we almost always see this is V is equal to IR. The voltage, or the electric potential difference, is equal to the current multiplied by the resistance R. And the SI unit for resistance we can get from the volt and the ampere. So a volt divided by an ampere is something defined as the ohm. And the symbol for it is the upside down horseshoe, or the omega symbol, capital Omega here. So that is the unit of resistance. The symbol of resistance is somewhat similar to a filament, because that's one example of a resistor is a filament in a light bulb. And it's this jagged line, right? Like Charlie Brown's shirt. So it's just up and down, jagged, and then it's usually labeled with the R for the resistance. We can also see a battery in this picture and a switch that you can connect to the circuit. Right? So what offers resistance? Well, that's to the extent that a wire or an electrical device offers resistance to electrical flow. That's what we would then call a resistor. So within the flashlight, the bulb filament is the electrical device that offers resistance to the electrical flow. The wires that connect the batteries to the filament are usually really good conductors, and so they offer very little resistance. So those aren't depicted in our circuit. We just have the resistance of the bulb filament and the wires to the batteries. Let's try out some numbers with this. So example 2, a flashlight. The filament in a light bulb is a resistor in the form of a thin piece of wire. The wire becomes hot enough to emit light because of the current in it. The flashlight uses two 1.5 volt batteries to provide a current of 0.4 amps in the filament. Determine the resistance of the glowing filament. All right. First off, I just find this so cool. I don't know why I didn't have a light bulb moment on this sooner, but that the way a light bulb works is that there's a piece of metal that's just glowing hot. Wow, that's awesome. Kind of scary, but it's neat too. At least the classic light bulb. So how can we solve this? We want to solve for the resistance. So we're solving for R, and we've been given the current and the voltage. So what might we use here? Well, this seems like a good place for Ohm's law, that the resistance is equal to the voltage divided by the current. So let's try it out. One more thing, is the voltage 1.5 volts here? That's where we have to be careful. There are two batteries here. And since there are two, which the problem mentions, the total voltage is going to be twice as much as in either of 1.5, right? It is 3.0 volts. Now we're ready to go. We can divide our voltage by our current and solve for the resistance. So here we've done that. Resistance is voltage divided by current, and it comes out to 7.5 with what units? Oh, the ohms. So there we have it. One other trick that some people have found useful is With Ohm's law, you can set up a triangle with V, R, and I, and you can put 2 slashes here, and this will allow you to then solve for whichever other one you want. So if you want the current, or I'll say if you want the resistance, because that's the one we have here. If you want the resistance, you can cover that up with your finger and can solve for the resistance with the voltage divided by the current. What if you want the current then? Well, if you cover up the current, then you have voltage divided by R. Okay, that's cool. And then what if you want to find the voltage? Well, in that case, you have R times I, or I times R. So that might be helpful to you. Sorry, this picture isn't good. You can probably find a better picture on the internet if you search Ohm's law, but that can help you with figuring out how you can rearrange it to solve for the different parameters. One more thing, we can connect back to the water pump analogy, and now we have a better picture of what's going on, right? The potential is one thing that sets how fast the water flows or how fast the current flows, but also the resistance. If there's a lot of resistance, we're not going to get as much current. If there's very little resistance, we'll get much more current. So hopefully that helps you picture the analogy. And here the water is shown as having to pass through a narrow section. That's another form of resistance, because you can imagine if it's a non-ideal fluid, then the water is going to be slowed by that narrow section. That can be the same with wire. You can have a really tiny filament like in the light bulb, and that slows it down. So this introduces Ohm's law. We'll be using it the entire chapter, so hang on to it.